So if you're in my class, then you'll know some time ago we did a question on compound interest. This is another question on compound interest, and the difference being that this time the interest is compounded continuously. So when you see a phrase that puts together the words continuous and compounding, such as it is here, compounded continuously, then we approach those questions in a slightly different form from the previous times. Continuous compounding has its own formula, and it's A equals P E to the power of RT. Okay, so before, where we were compounding monthly, weekly, quarterly, there was another variable called N in the equation. But if we're compounding continuously, so make sure you look for that phrase, compounding continuously, because it changes the formula. Our new formula, A equals PE to the RT. Okay, now the P, R, and T, their meaning doesn't change. The P is the principal, the amount that you initially invested or borrowed. In this case, it's borrowing. So the principal here is $60,000 that Margaret borrowed. Okay, $60,000. The interest rate is 3.5%. So 3.5%, but if you remember when we did compound interest before, we expressed that as a decimal. Do the same here. That's 0.035. And then T is the length of time that money is invested or borrowed for. In this case, Margaret is going to pay off her loans in 25 years. So T is going to be 25. Okay, so if we follow the formula, we have A is equal to 60,000 times E to the 0.035. I apologize for my voice suddenly going up there. The part of 25. Now, if you remember, we did this before. Okay, so when we did these questions before, this is the first thing that we multiply. So 60,000 times E. Let's go to our calculator and do this. So if we bring up the calculator, it's 0.035 times 25, and that gives us 0.875. So here we're going to have 0.875. So it is useful to multiply these two first. And now we're just going to type this into our calculator as it is. Nothing new here, so bring up the calculator again, clear what's on the screen. And then it's going to be 60,000. Then E. So to get E to second, and you hit the LN button. And it's 0.875 that will go inside parentheses here. Okay, and hit enter. That gets 143,932. 143,932. And let's just look at it again to get the numbers after the decimal point. 5176. So 5176. So to the nearest cent, that would be, cut it off after two decimal places. We're going to get $143,932.52. Okay, so that's how much money that Margaret will end up paying back. Now, the second question was, how much of this is interest payments? Well, she borrowed initially 60,000, so anything above 60,000 is interest payments. So, to find the interest payment, we're going to subtract 60 from that amount that she pays back. So it's 143,932.52 minus 60,000. And that's going to give us 0 from 3 is 3, 6 from 14 is 8. So $83,952.52 in interest on a loan of 60,000. So she ends up paying more back in interest than she did in the actual loan itself. which may make some impression on you as to the value of borrowing money. Okay, thanks for watching.